Hey guys, welcome. This video is for my AWS Certification Guide series. In the previous video of this series, we have been talking about AWS networking using VPC. There, we studied the on-premises network architecture and then we migrated that architecture to AWS from scratch. So this is where we ended up last week. If you didn't watch the video, I'll post a link up here. But anyway, let me quickly go through the network architecture we came up. So we are using AWS. So this is what this outer bound means. And we spin up an VPC or virtual private cloud inside our AWS region. So when we are defining a VPC, we had to assign an IP address range, which we thought of going with 10.0.0.0/16 cider block. And afterwards, we further divided that IP range into two subnets. We designated one of these subnets as a public subnet by attaching the internet gateway into its route table, so that any instance that we spin up in this public subnet can have the ability to talk the internet via the VPC router here. And we are going to add our web server inside our public subnet. So what about the backend server? So backend server will be added into the private subnet, which does not have a route out to the internet gateway. Can you see? So this is the route table of our private subnet. It does not have a route out to the internet gateway, but it has a route out to the net gateway so that our instances in the private network can talk to internet via the net gateway in order to fetch any security updates or any other updates from internet. But no traffic is allowed to talk to backend servers since we don't have an internet gateway attached. Now I have a question for you guys. So we mentioned that web server is in the public subnet where the internet gateway is attached. So can someone outside our network access to our web server via internet? Just think about the current setup that we have right now. Well, the answer is no. The reason is, guys, we yet have not defined the security for our network architecture. If you can remember our on-premises network, we had firewalls, right? So we had a firewall for our web servers and also we had a firewall for the backend servers. So when we migrated to AWS, we have to define firewalls as well. And in those firewalls, we have to define who can actually access our web servers, on which ports, and over which protocols. Unless otherwise we define those security aspects, our instances cannot be accessible over the internet. So let's look at what are the ways that we can secure our cloud network architecture. Now in AWS, there are two main constructs. So those are NACL or NACL we call it, and security groups. So NACL stands for Network Access Control Lists, and security groups are basically the virtual firewalls. So our on-premises architecture had firewalls here. So similarly, we have virtual firewalls and we call them security groups in AWS. Now, let's say this is one of our subnets. Now I have drawn only one subnet and I have spin up two EC2 instance in that subnet. Okay. Now this subnet is within our VPC and it has a VPC router attached as well. Now guys, once you have spin up an instance, let's say EC2 instance inside our subnet, how can it really talks with the subnetwork? So that is nothing but via a ENI. So ENI stand for Elastic Network Interface. If you take a physical server, it always has a network interface card. We call it NIC. So this is the virtual network interface card which is attached to a virtual server. So obviously in a virtual server we cannot have NIC directly attached because it is virtual. So we need to have a virtual NIC and which is called ENI, Elastic Network Interface. So ENI is the interface that our virtual servers EC2 instances talk with its subnet. Now security groups operates at ENI level. Can you see? Security groups operate right here. So what really is a security group and what is the purpose of that? Well, a security group is a virtual firewall and it controls what traffic comes into the instance and what traffic goes out of the instance. So it either allows traffic or either block traffic that is coming in or out of this particular EC2 instance. So security groups operates at the instance level especially at the ENI of the instance, and it gives you the control to define inbound and outbound traffic rules to your EC2 instance. So inbound is the traffic coming into the instance, and outbound is traffic going out of the instance. So what are the points that we have to remember here? First, and the very important point, is that security groups operate at the EC2 instance level, at the ENI of the instance in particular. And security groups are virtual firewalls, and they allow or block traffic in and out of the EC2 instance. And here, an instance can have up to 5 security groups. So if you have more than one security group assigned to a EC2 instance, AWS will always check all the security rules before sending traffic into the instance. And then security groups are stateful. So that means if you allow an inbound traffic on a certain protocol for a certain port, you do not have to specify the return traffic through that port over that protocol again. So once you allow the inbound traffic, security group will make sure the outbound traffic is also allowed. Now this is different in network access control list. In network access control list, they are stateless. So in that case, although you allow an inbound traffic on a certain port, you have to explicitly mention allow or block the outbound traffic as well. And in security groups, it has only allow rules. You don't have deny rules, but in network access control list, it has both allow and deny rules. Now, if no rules is defined in a security group, the traffic is blocked. So it's never allowed any traffic into the instance if there's no rule is defined for a security group. Now, these are the main important points that you have to remember in terms of security group. So let's move on. How about NACL? Now, we learned that security groups operate at ENI of a EC2 instance. Now, NACL operates at the subnet level. NACL is like a gatekeeper, right? So the traffic is flowing from in this direction. So it will first meet the NACL that is operating at the router or a subnet level, and then only it will meet the security group at the ENI of the EC2 instance. So if we consider the EC2 instance, the first level of defense is the security group, and the second level of defense is the NACL or network access control list. Since NACL is defined at the subnet level, all the rules that we define at the NACL is applicable to all the instances or all the resources inside the subnet. So let's see what are the points that we need to remember. The very first one is the NACL operate at subnet level. So it's basically a gatekeeper of the subnet. NACLs are stateless, as I mentioned earlier. The return traffic has to be explicitly allowed even though you allow the inbound traffic. And unlike security group, NACLs can have both allow and deny rules. So if you are to deny a certain traffic from an IP address, so let's say that you know an IP address or an IP address range that you want to block from your network. So in that case, you cannot use security group because it does not have the deny rule. So there you have to use NACL because it supports deny rule. And here's another important thing. NACL rules are evaluated from the lowest number to highest number. So in NACL, when we are defining a rule, we have to specify a number. So those numbers can go from 10, 20, or it can go from 100, 200, etc. Right? So when evaluating those rules, AWS will start from the lowest number and it will go to the highest number. And the most important thing is AWS will directly apply the rules defined at the lowest numbers immediately. So the lowest numbers have the highest priority. And we discussed this. NACL rules are applied to all instances within the subnet because it is defined at the subnet level. So when you're architecting your application, it's best to list down all your resources and then decides who needs to talk to whom. And then we can create security groups and network access control lists depending upon that communication pattern. So now let's add security groups and network access control lists to our architecture and control the communication in our network. So here's our network architecture, and we are going to add a security group to our web server. Remember, security group is applied at the instance level, particularly in the ENI, and we are going to create a security group that allows traffic on HTTP protocol on the port 80 from any source. So now what is a source here? So source is any resource or any appliance that is trying to communicate to our instance. So that is where the request is originated, right? So the first rule says, no matter whatever the resource is, no matter whatever the IP address, please allow HTTP traffic on port 80. Since this is a web server, we must have to allow this. Otherwise, they cannot access our web server. Similarly, we are going to allow HTTPS traffic as well from any source. So once we define this security group, our web server can be accessible over the internet from HTTP or HTTPS protocols. Now, one thing to remember, guys, here we did not specify NACL rule because when you create a VPC, it will create a default NACL that will allow all inbound and outbound rules. So here we just have to define our web server security group and configure these two rules. Then it is accessible over the internet. So what about the backend server? Do we really want to allow anyone in the internet to access our backend server over the internet? Do we really need this? No, right? Because our backend servers is consist of our databases, application servers, etc. So if anyone can access our databases over the internet, so that will be a real security threat. So instead what we will do is we will allow only the web server to access our backend server. So how can we do that? Basically, we have to define another security group for our backend server. Here we go. So we created this backend server security group which allow all TCP on the port 4000. So let's say our backend server is running on port 4000. So we define the port 4000 and which source do we allow it? We are allowing any resource that has the web server security group attached. So that is what this web server security group label means. So when you define a security group name, instead of an IP address or an IP address range, AWS will make sure to apply this rule to any resources that has this security group attached. So in this case, web server security group is attached to web server in this instance. So when the web server is trying to talk to the backend server, this rule will be evaluated. Alright guys, so now one other thing you have to notice is both these rules in these two security groups are inbound security rules. So that means these rules are applicable to the traffic that is coming into the instances. Here we did not specifically define our outbound rules because of the statefulness feature in security group. So that means if we allow HTTP on port 80 for any IP address, the return traffic will also be allowed. Alright, so I think now you guys have understood all the theoretical parts. Now it's time to practice it. So in the next video, we are going to build this entire network architecture on AWS from scratch. So stay tuned guys, I'll see you soon. Thanks.
Wow.